Hello, Hera.
Hello, Hans. You look troubled. What is going on?
Well, I'm arranging a poker game at my next cat get-together, and I'm using treats as chips. The problem is that every 20-pound bag of treats at the animal grocer has different number of treats, so I am confused. How will I know how many treats I can expect to get when I buy a bag from a specific brand, you know?
I think I can help you. I will take some samples of treats from bags manufactured by different companies and get back to you. Hans, this is what I found. Interestingly, every bag had the same mean, or average number of treats per pound, but had different number of treats per pound.
How is that possible?
I'll show you. I did 20 measurements, each weighing 1 pound, from a Better Treats bag. There was an average of 52 treats per pound. Take a look at how these measurements were spread around the mean. As you can see, one measure had 40 treats, one measure had 43 treats, one measure had 44 treats, one measure had 47 treats, 3 measures had 48 treats, 2 measures had 49 treats, and so on. The mean number of treats per measure was 52 treats. Then I did the same with a bag of treats from Even Better Treats. Again, there was an average of 52 treats per pound. But take a look at how these measures were spread around the mean. As you can see, one measure had 46 treats, one measure had 47 treats, one measure had 48 treats, 2 measures had 49 treats, 3 measures had 50 treats, 2 measures had 51 treats, and so on. Yet, the mean number of treats per measures was also 52 treats. So knowing the mean number of treats will not help you differentiate between the brands, but how the treats are spread around the mean will help you.
Wow, impressive work, Hera, but how will this spread around the mean help me?
One measure that is often used to infer, predict, or describe data of a population is the standard deviation. Deviation is a statistical term which refers to variation or variability, while standard denotes something typical or average. A standard deviation is an estimate of the variability of the population from which the sample was drawn. In our case, the variability of number of treats per pound in a bag of treats, which is derived from the estimated average difference between a single score or measurement and the average of all scores in the sample. The standard deviation can be used to estimate the probability of finding a bag of treats with a particular number of treats or a range of number of treats, and much more. In our case, Better Treats had a standard deviation of 6 treats, and Even Better Treats had a standard deviation of 3 treats. If we assume that the number of treats per pound in a bag of treats has a normal distribution, remember the normal distribution video? Approximately 68% of 1 pound of treats from a bag of Better Treats will have between 46 and 58 treats, and of 1 pound of treats from a bag of Even Better Treats will have between 49 and 55 treats. The 68% comes from the area under the normal distribution curve between one standard deviation below the mean and one standard deviation above the mean.
So, while the mean number of treats per bag couldn't help me decide which bag of treats to buy, choosing a bag with a smaller standard deviation will decrease my chances of getting less treats and being disappointed. But, on the other pole, choosing a bag with a smaller standard deviation will decrease my chances of getting more treats. It is more important to me to reduce the chance of being disappointed than increase the chance of getting more treats. So, I think I'll stick with the Even Better Treats, which has a smaller standard deviation, but more certainly less range of treats per pound. Thank you, Hera.